All right, ladies and gentlemen, the founder of Bitnetics and SmartVox, I now present to you guys Eric Loyd.
Good afternoon. Oh, thanks. Oh, that sounded loud. Is this okay for everybody to hear? Yep. Okay. So we're going to talk today about Amazon Web Services and specifically the EC2 virtual computing that they do and how our voice over IP platform utilizes Nagios to dynamically adjust how many servers we have running so that we can only pay for what we need. And I'm going to apologize in advance. The name of the company is Bitnetics. The name of the platform is SmartVox. But we're kind of blurring the lines between those two things, so you may hear me or see me kind of use those two things interchangeably. So Bitnetics, for now, is the name of the company. We may change it to SmartVox at some point, but let's get into it. So a little bit about Bitnetics. Myself as well. Skip through a lot of this pretty quick. So founder and CEO, we've been in business since 2006. We've been doing voice over IP since 2007. We made it our primary focus in early 2012, late 2011, early 2012. Got a couple of awards for our communications product and services, and we're located in Rochester, New York. Been using Nagios, and that's Nagios Core, it should say, since 2004. Both for ourselves and for some of our former IT consulting customers. I was here last year, for instance, doing a presentation on a case study for Nagios implementation at Kodak that we did. Anybody remember Kodak? Little company, about 3,000 people now. So history of SmartVox, which is the platform, again, pre-2012, it wasn't even called SmartVox. It was just our voice over IP platform. We sort of sold it. We didn't really. It was kind of like, oh, yeah, we can do this for you, too. But we were an IT consulting company. So our voice over IP service was only about 10% of our business, and we predominantly did it with customer premise custom installations. So every customer got something different than every other customer. As you can imagine, growing that is pretty complex to maintain and support over time. So the nice thing about that was we had control over the customer's network because we were also their IT department. So we could manipulate traffic, we could do what we needed to make sure that the voice over IP traffic worked well. 2012, we focused on voice over IP and we moved to a hosted solution. So we're not talking anymore about customer premise equipment. We're talking about moving our platform into the cloud and providing services as you would buy a web server or email service or anything like that. We just put a phone on your desk and everything else is on our platform in the cloud. To do that, we make use of the Amazon Web Services EC2, which I can never remember what it stands for. Extensible, something computing, something or other. Anyway, elastic cloud computing. Thank you. Yeah. To me, it's just virtual private servers. So the way we've done this in 2012, when this was kind of our generation 2, was we built a box for every customer. They got their own box, their own private box. It did everything that they needed to have done. We didn't make use of any SIP proxies or media servers, and the only requirement that the customer had was network connectivity and the appropriate bandwidth. 2013, we copyrighted, we did a bunch of stuff, kind of sort of created our third generation, and this involves multiple proxies, multiple registrars for the phones, a bunch of configuration servers and media servers. Talk a little bit more in detail about some of this. In June, we launched a new, we'll call it kind of a marketing campaign. It's really more of a core focus in what we're doing, which is a Mission Matrix program. The reason I bring this in here is not to be a salesperson, but this was a program where we could go to nonprofit organizations and have them refer our service to other businesses, like people on their boards of directors or so forth. And then the nonprofit would get a 15% continuing return of whatever the revenue was from those companies. So it was a way to get the nonprofits to basically market for us. And the reason that I bring this up is because it was such a huge, successful program for us that it has caused some pretty big growth in a fairly short amount of time that we've had to deal with. Luckily, we had the pieces in place to be able to do that without too much effort. So we started leveraging the Amazon Web Services platform for geography. Each customer still gets their own EC2 server. as a registrar or a proxy for their phones. We'll talk more in detail about some of this specific voice over IP technology in a minute. And if you imagine, we're predominantly in the United States, so if you imagine a map of the United States from your perspective, every customer has their primary server located in their geographical area, and then they have a backup that's to the west, in whatever the next westernmost data center is from Amazon. And if you fall off the west coast, you wrap around back to the east coast. So Virginia fails over to California, to Oregon, back to Virginia. Media servers, which are based on asterisk, for those that are interested, are based on the number of simultaneous phone calls, conferences that we need, and some other things. Primarily, that's what gets dynamically adjusted. So we've got a lot of Nagios monitoring on those media servers. We can locate those in the zones, what Amazon calls zones, what most of us would call data centers, based on how it's going to help provide service to each, get the right button, to each customer based on that geography. Now, voicemails, called detail records, CDRs, these are all things that are stored in a database. So we push all that back to yet another component of Amazon Web Services. So we're storing that in a MySQL database that runs on dedicated servers within AWS. To some extent, we dynamically adjust those as well, but we do that for other purposes than capacity specifically, and we'll get to that at a later slide as well. So for those of you that, actually, does anybody not know Amazon Web Services? I don't mean you have to be a developer, but does anybody not have any familiarity with the service? Okay, so briefly, flip through this. La la la. Yep. One too far. Get back to it again. Cloud-based services, storage, DNS, database, private servers, the EC2 stuff. See, I did know what it stands for, Elastic Computing Cloud. So there's virtual servers in the AWS zones. There's a primary center in Virginia, primary center in Northern California, and a primary center in Oregon. There's also one in the EU, I think it's in Ireland, if I remember correctly. There's a couple in Tokyo, Singapore, somewhere else, and there's one in South America somewhere. Right now, we're only using the ones in the United States. Within each data center, there's potentially multiple sort of sub-data centers. Like I said, you and I would call them data centers. They call them availability zones. So we can leverage that functionality in the way that Amazon has structured that to provide failover, redundancy, and geographical-based distribution to our customers. So you pay for what you use, basically. If the box is up and running, you get charged. If it's not, for the most part, you don't. You can reserve instances. If you reserve an instance for a 1 year or a 3 year contract, you get a better rate. But fundamentally, you pay by the hour that it's up. You pay for storage. You pay for the bandwidth that it uses. Reserved instances are instances that you know you're going to use. They're going to be your configuration server or your Nagios server or something like that that you know you're going to be using on a continuous basis. A spot instance is a temporary server that you can request. The cost of that is based on current market cost, so it's a commodity. It goes up and down. You basically bid and say, I'm not going to pay more than 10 cents per hour for a server. And if there's one available, if they have resources to give to you, you can get it. When the why does it keep doing that? When the box is done doing what it's doing and you shut it down, see if this works. I guess not. And you shut it down, when it's terminated, it disappears. You're no longer charged for it. So it's a temporary box. And if you plan your installation images correctly, you can bring it up. It knows what image it's going to load. It can run. It can do its task. And when you shut it down or when you stop doing the processing that you need, it will shut down. It terminates. It disappears. You stop getting billed for it. So we make use of those. Okay. We make use of those spot instances a lot. So there's a lot of costs involved because Amazon wants to get their money. A lot of variables in there, but basically for the sake of argument, we'll say that a reserved server costs about $2 a day to run. It's not a lot, unless you got 1,000 of them. Reserved instance pricing, like I said, is potentially based on contracts. What size box do you want? Spot servers can run, again, commodity. It can be cheap to get one for a little while, or it can be expensive to get one for a little while. For our argument, we assume about 10 cents per hour to run a spot instance. So we're a voice over IP provider, and we do this with multiple customers and multiple geographies, but we aggregate the calls that they're making to our media servers and our SIP proxies. So we think in terms of 50 call blocks. So at any given time, we're going to have between 0 and 50 calls, or 51 to 100 calls, or 101 to 150 calls. You know, we quantize down to 50 simultaneous calls. Anything, we size our resource to boxes so that they're based on a 50 call volume. If we need more than 50 calls, it's time to bring up a new server. So 50 calls is one spot instance. 2 media servers, 100 calls, 2 spot instances, so forth. Bandwidth and storage, you got to store, I keep hitting this, you got to store your log files, you got to store your base image, things like that. You got to pay for that storage. I can't remember which it is. You either have free incoming bandwidth and you pay for outgoing, or you have free outgoing and you pay for incoming. It doesn't matter to me, because for us, all of our traffic is essentially symmetrical. So we pay for half of the overall bandwidth that we use, because AWS lets you get one of them for free. I think it's incoming, but I don't remember. AWS.amazon.com, and you can look at the pricing and figure it out. So anytime we can reduce our AWS usage, we're reducing our cost. Why does it keep doing that? I don't know. Sorry about that. And if you read it really fast. Okay, so we don't pass our cost savings on to our customers. Don't tell them. If it costs $10 to run the box today, and it costs $8 to run the box tomorrow, we just made $2. So why do we want to use Nagios? Well, obviously we've been using it for a while, so we have an extensive use, or extensive experience in it. We're a Nagios reseller, so that's always a plus. Obviously the functionality of Nagios itself is pretty important to us. It gives us the ability to monitor. It gives us the ability to integrate with Twitter, which is how we do most of our notifications. And Eventum, which is what we use for our ticket tracking system, works pretty well with Nagios. Quick plug, if you come back tomorrow, I think at 10:30, I'll be doing a live install of Nagios on a AWS EC2 instance, including setting it up for Twitter notifications and breaking things and seeing how that works. There's no cost if you're using Nagios Core. That's always good. The framework that it provides gives us great flexibility. If you're here, you know Nagios. At least if you're in this room, you know enough about Nagios to know what kind of flexibility it provides. Check MK and live status. Those are two great things that if you don't use them already, you want to look into for Nagios Core. And we make a great use of custom notifications, which is our Twitter notification, and our custom checks, which have to go check various things within our voice over IP platform. I have no idea if this last thing is going to show up. Okay. The ability to cookie cutter our installations. We have done our best to get away from every customer is different and unique, and we've moved to the other extreme end of the spectrum where we want every customer to look like every other customer. So as best as we can, that means that all those SIP proxies and all those media servers, they look like all the other SIP proxies and all the other media servers that we have on our network. And so everything can be cookie cuttered and copied, and therefore the configuration management becomes really easy. All we have to do is talk about a machine name, what kind of machine it is, and it looks like all the other machines that are of that type of machine. So the initial hurdles that we have in doing this is with customer premise equipment, we have no real control now over what the user has at their office. Now we're talking businesses and nonprofit organizations. We're not talking about consumers. So we're generally talking about small businesses which may or may not have an IT person on hand. So they may or may not have somebody who knows networking. And they might have just gone to Best Buy and bought a nice Linksys router and turned it on, and it doesn't do crap for voice over IP. Some of those routers actually think they're helping that ALG setting. If you've ever seen that on a router, turn it off. Don't use it. So we need to be able to remotely either configure or reconfigure the phones. So we're going to take a break here from what's on the slides and tell you a little bit about what we're doing from an architecture standpoint. We have desktop telephones, they're Cisco model telephones. We use SIP for the communications back to our servers. And for those of you that don't know how voice over IP works in a general sense, the endpoint, the telephone, needs to talk to a proxy, which may talk to other proxies, to be able to send a call from where you started to where you want to be. If your telephone just wants to talk to another IP address, you don't need a proxy. You just punch in an IP address. But if you've ever tried to dial an IP address on a DMTF telephone keypad, it's kind of awkward. So most people dial telephone numbers. So we have a telephone number that is my, if I find it behind me, that is my cell phone. My mobile phone has a telephone number. If I'm at my desk at my office and I want to dial that mobile telephone number, the phone on my desk doesn't have a clue how to talk to a normal telephone. So it has to talk to a proxy. The proxy may or may not have a clue how to talk to a normal telephone, but he knows somebody who does. And this whole proxy chain takes an effect until you get to somebody who converts between the voice over IP world and the public telephone world, and now you have a connection. Same thing happens in reverse. So those phones need to be registered to a particular registrar so that when those phone numbers are called and they come into the platform, the system knows where to deliver the end phone call. So we need to be able to reconfigure phones without having the phones come to our office and have somebody sit there and reconfigure a phone and send it back out to the client. We'd much rather have the phones go directly to the client and have them just plug them in and go. And if we need to make programming changes, we'd really like to be able to get through their firewall and be able to do something about it. So again, we have no real control over what they have at their sites anymore using the hosted model. Again, we want to figure out how to cookie cutter these devices, and we want to be able to monitor our upstream providers so that we can separate an actual failure from an apparent failure. We have multiple providers, those proxies, that we can send phone calls to. If one goes down, it might be a bad thing, but we can still send phone calls to another one. The overall platform still functions. So we want to be able to monitor all this, and I have no idea what's going on with that last little thing there, and I got to get through it all again, see what it said. So if something's broken, the overall functionality, all right, you got that. So remember this, DNS SRV records are the key to our platform. If you want to bring us to our knees, break into our DNS server and change all our SRV records, and you will have complete control over all of our customers and all of our voice over IP traffic. Keep that in mind. Everybody know what an SRV record is? Anybody not know what an SRV record is? Okay, so familiar with DNS at least? So an SRV record is sort of a way of, if DNS is saying, I want to give you a name and you're going to give me an IP address, SRV is saying, I'm going to give you a name and a service, and you're going to give me an IP address and a port. It's kind of the way to think of it, in simple terms anyway. So it's kind of an extension to what DNS provides. So we have our provider, and our provider sends phone calls into our border proxies. Our border proxy sends the phone call to the customer proxy, and the phones are registered with that customer proxy, so the phone call knows where to go. We have multiple customer proxies. We have multiple border proxies. Some customers have multiple proxies themselves. There's all these proxies coming in and going out and all this other stuff. Keeping track of what they are all are can be kind of annoying. So the inbound the inbound provider sends that call to the border proxies. The border proxies figure out, based on some database configuration information, what SIP proxy that customer belongs to, sends the call there. That SIP proxy then figures out where to send it. Am I sending it to the phone? If they answered the phone, great, I'll send the call to the phone. If they didn't answer the phone, now I got to do something else with that phone call. Most of the time, that's going to be send it off to a media server where we can record the phone call in the form of a voicemail, which gets stored in a database. Hey, there's no blinky thing there. So we have this gigantic SmartVox AWS EC2 Provisioning Database. It's not really actually very gigantic at all. It contains some basic customer information. And because some of our customers have multiple offices in different geographies, we have a different account based on geography or location. So customer that's based in New York City but has an office in LA is going to have two accounts because we need to keep track of which proxies belong to the local geography. So we need to keep track of the geography in New York. We need to keep track of the geography in California. In addition to this, we keep track of the number of phones, give or take, how many voicemail boxes they have for billing, and all this other stuff that we have to worry about. This whole thing is kind of a gigantic, hacked together set of MySQL pushes and pulls into databases and bash shell scripts that pull stuff out and do some math and figure things out. But in the end, it figures out you've got one customer with 2 locations, therefore you need 4 proxies. 2 for each location, by the way. It goes and creates SRV records so that we have the name of the machine, the type of machine, and the customer is included in that DNS entry. So now we can literally look at a DNS address and know exactly who that proxy belongs to, what its purpose is, where it is, whether it's a primary or failover, a whole bunch of other things. Media servers and voicemail entries, these all get created as part of the provisioning process as well. The phone provisioning, well, the phones need to know which proxies to proxy to. They need to know what to put on their screens. They need to know how many lines they have. They need to know what those extensions are, usernames, passwords. All that stuff is done through the phone provisioning. So all this is tied together, and if we look at the number of phones that we bought for the customer, we actually place an order automatically when this gets done to our provider, plus a couple extra in case some of them break over time, so that we don't have to pay somebody to go from, here's the customer intake screen, and type something in to an order entry screen with one of our voice over IP telephone providers. That's all handled automatically. So when that customer signs on the dotted line and data goes in this provisioning database, out the end comes a whole bunch of configuration files and then some phones. And the phones get automatically drop shipped to the customer. So we never see the phones. It takes about 3 days for that process, depending on where you are. So when, okay. So when you create a spot instance, you say, I want to create an instance with this particular install base image. We have a couple different base images based on what that machine's purpose is going to be. We've all done that configuration beforehand. You take a snapshot if you're familiar with virtual machines. Now you can go clone that image anytime you want. So the first thing you do is you say, I want to create an image, or I want to create an instance using this image. You wait a little bit. You get a request ID back as part of that. You ask, hey, are you done yet? You wait a little bit. You say, hey, are you done yet? And when you're done, it says, here's your instance ID. As part of that, you can query it. You can get the IP address that was assigned to it. So now you know what kind of machine you've just made, who it's for, what its purpose is, what its IP address is. Update some DNS information. This is how this all works. So when the spot instance is done doing its work, it shuts down and it terminates. So we have no more expenses for these burstable resources unless we're actually using them. This is, hopefully we're going to get this last thing here. Oh, I guess not. So this whole process sounds a lot to me like a Nagios event handler. Now, something happens, I'm going to go take action, I'm going to go make something, and when the thing is done, it will terminate. So you have this custom image that includes asterisk or whatever else it needs. And as part of this part of the startup script for asterisk, it is started through, these are Linux boxes, so it started through @crc.local, running CentOS on these. And it says, go start asterisk. And the next line is, in the go start asterisk script is, wait for asterisk to finish, and then shut down. So the only thing these boxes do in this case for a media server would be to start, run asterisk, wait for asterisk to finish, and then terminate. So we have an instant spot instance that comes on when we need it, terminates when we don't. Trying to make that very clear. So we have the same basic idea for starting and stopping proxies, except they tend to be a little more static than media servers. We usually bring them online more often than we're bringing them offline. But the whole process, the whole platform now could be adjusted dynamically. We have a script that can go make media servers, which are those things that handle voicemails and telephone calls. We have a script that can create proxies, which are the things that handle where to send those phone calls. We have a database that controls them all. Kind of sounds like Lord of the Rings now. So because our platform adjusts dynamically, our cost of goods sold, COGS, adjusts appropriately. We use more, we spend more. We use less, we spend less. So hey, let's look this up in Nagios. Quick, more ideas about what you can use spot instances for. You do a database dump. So our call detail reports, or CDRs, contain perhaps multiple lines in a database for what happens when somebody calls us. Did it go and they transferred? Did it go to multiple phones or one phone? Did they answer? Did it go to voicemail? All these other things. So what we can do is we can turn up a new database on a spot instance real quick, copy from that box to this box, and then have the original box continue to do stuff while we're running reports off that copy. When the reports are finished, we don't need it anymore, terminate it, and it goes away. Bye-bye. So you can distribute your web server load. Uh-oh, Nagios says our web server's running hot. Assuming you have a common file system of some sort that you can share that web server data across multiple machines, pop up another server, add it to your DNS rotation, instant on-demand capacity. When you're not using it anymore, terminate it. It goes away. You don't pay for it. Anything you want to do, let's see, what did this say? Repeatedly, not for a long time, and only when you have to, are good things to use spot instances for. So we've got spot instances for everything except some core functionality. Like Nagios, for instance, is not running on a spot instance. So hey, what if we took Nagios and we had it manage all those spot instances? Sounds like a great idea. So rather than create all those virtual servers when we create customers, we just let Nagios do it. So we tell Nagios, hey, we have this dynamic host config file that we throw in as part of the provisioning process. It gets regenerated through cron jobs and extracts out of the database that says, here's a list of current customers. These are the machines you should be monitoring. If it finds the host in the configuration file, but it doesn't find the host is up, it assumes that we need to fire the event handler. And the event handler says, hey, Amazon, is this instance running? And if it is, or rather if it's being turned up, then we say, okay, great, it's coming into play. If it's not running, it says, okay, start one. So now Nagios is looking at its configuration file, which was generated by our provisioning process, and turning up machines literally as we need them. We're not going in and manually doing this process. We update DNS every hour with a 59-minute time to live. DNS is very important to us. So this way we can dump those new names that we just generated, the new names that we just generated here, we dump into DNS so that we keep track of who's got what and what it's doing. Phone provisioning, same kind of thing. We do a bunch of extracts. All this stuff gets handled through HTTP configuration files that the phones request. And since most firewalls allow HTTP requests to go in and get responses, that takes care of most of our customer premise firewall issues. And TFTP and some other options really kind of suck if you don't have a good firewall. So all the configuration scripts are basically built on the fly when the phone makes a request by looking in this provisioning database. What is this talking about? Oh. So we have primary and secondary master and slave configuration servers that are also AWS boxes that are providing these services to the customers. So when you get a phone from us, you're going to get a phone. It's going to arrive in a FedEx box or whatever, and you're going to get a URL that says, put this into your browser once your phone's on your network, and it will go find your phone based on looking at the database. It will know who you are. It will find out what the MAC address is for your phone. It will find it on your network, assuming you're on the same network, and it will go reboot the phone and tell it where to get its configuration information from. Configuration information may include firmware updates. That all happens automatically. The phone's going to flash and reboot and flash and reboot, and when you're done, 5 minutes later, it's going to come up. It's going to be your phone. You can pick that phone up and put it on any desk and plug it into any network connection on the planet. It's still your phone. Let's see what happens here. The entire process takes about a week to go from customer signs the order to fully functional, assuming there's no problems with shipping phones. And most of it is hands-off on our behalf. The only thing we have to do is get those customer intake forms into the database, and Nagios does the rest. Monitor. So Nagios is looking for hosts. That's always good. If it doesn't find hosts, it creates them if it needs to. That's cool. We don't consider the SIP proxies necessarily to be spot instances, so it creates them, but it doesn't necessarily delete them. They're dedicated to the customer, so they're only terminated as part of a decommissioning process. But they are still terminated when that happens. So again, we don't pay for something we're not using. Nagios is looking at the health of the services running on the box, are on the boxes, so it's figuring out, hey, are we working or are we not working? And it can potentially reroute phone calls if it finds that there is a server or a service that we're providing that's not functioning. It can go update that configuration file that we use to batch update our DNS, change those SRV records around so that now customers are pointing to different servers automatically within a 59-minute time frame anyway. And the problem kind of fixes itself on behalf of the customer. We still have a problem, but the customer's still working. Troy, we store all of our performance information. This is pretty important for the next couple slides because we make use of this on a historical basis to figure out how much did we use yesterday, how much did we use last night, how much did we use last hour, so that we can make some predictions about what we're going to use today. And we send a bunch of notifications with Twitter and email, and if you come back at 10:30 tomorrow, you'll see more about that. So we use Nagios for capacity planning, in addition to monitoring and provisioning. Again, we quantize by 50 simultaneous phone calls. We make use of this performance data. We have cron automatically add and remove servers based on what we think our history has been on performance. So we have cron leverage that event handler that Nagios uses to go tell Amazon to go make a box or delete a box. So kind of integrate it that way so that we have this little custom thingy called delta C. C is as in number of calls. So that's the change in calls per historical period. And what happens is Nagios figures out, did we go from 35 calls to 40 calls? Well, we didn't span that 50 number quanta, so the delta is 0. So we're only looking at 50 call blocks. So we had one 50 call block last time, we have one 50 call block this time, so nothing's changed. So we call that an okay. If the delta is negative, means we had 3 call blocks before, and we have 2 call blocks now, that means we have too much capacity. We have space, we have capacity for 150 calls, but at most we only used 100 calls. So we call that a warning, and wrong button. And if our delta is positive, then we need more capacity. So if our delta is going up, that means that last time we had space for 50 calls, but now we're actually using 60 calls. We need to increase capacity. So the event handler looks at all the state, figures out what it needs to do, if it needs to do anything at all, and says, do we need to stop asterisk, which will then terminate the box, or do we need to bring another one, in which case it falls back to that whole provisioning thing. So the capacity adjusts with usage. So we're going to look at this Delta C custom Nagios module, at least at a high-level overview. It looks at the last 3 times it ran on the host, so it's looking at data over time, not a long period of time, mind you, but a fair amount of time. But we look at, again, this quantum of 50 calls. Kind of said this on the last slide, didn't we? So if the delta C is 0, we're not changing capacity. If it's less than 0, then our call volume is dropping. We SSH to the box using keys that are pre-configured because we used a known base image to create the box, and we tell it to stop asterisk. Asterisk has a really cool ability to say, wait for all your current phone calls to be done, and then stop. So we're not terminating it in the middle of somebody's phone call. We're just saying, hey, when you're not busy, I want you to exit. And because the startup script will shut the machine down when asterisk process exits, effectively that's a termination of the box when it's not doing anything. Box is a spot instance. We're not using it anymore. We don't pay for it. And if we're getting higher delta Cs, we'll go start that provisioning process to create a new box again. Blah, blah, blah. It reduces cost, right? We all know that now. So how delta C works. Let's assume we're going to create a new host. Here's the command. You're going to type in Amazon on an instance which has the Amazon API on it. You can type that command, if you're me, and you will get a new instance in a few minutes. Key things to look at are, this is the base image that we're running. So this is pulled out of a database of base images that we run. That happens to be a media server base image. Yippee. This is how much I'm willing to pay for it. I'm going to pay no more than 4 cents per hour for this box. If there are no resources available at that rate, I won't get a box. my script is smart enough to say, I didn't get any at 4 cents a minute, let's try 5. I didn't get any at 5, let's try 6. So it tries to make a minimum bid, kind of like it's hacking eBay. Some security information for how we're going to log in. This is an SSH key. This is what security group we're going to use. This is the type of Amazon Web Server EC2 instance we're going to create. This is how many we want. And most importantly, it is a one-time creation. A one-time means when you're done, terminate. So when this happens, when this command is executed, we're going to get back something that looks like a MySQL statement with all the little columns and dashes and all that kind of stuff. So we can use awk and we can pull out some columns and we can get out this spot instant request ID, which in this case was SIR 722 Fox 4 Echo 34. Here's your next command. So you take the instance request, you take the spot instance request ID that you just got, and you keep querying it to say, are you there yet? Are you there yet? Are you there yet? Are you there yet? And if it doesn't work, one of two things happen. You had a horrible failure in your base image and it didn't validate, or nothing was available at the price you wanted to pay. So this could take a few minutes, but generally speaking, if it all works, about 3 minutes from now, you'll have an instance ID. And now you have an instance ID that's not quite running yet, but it started. So you can query the instance, are you ready yet? Are you ready yet? Are you ready yet? Until it's up and running. And these are, don't tell anybody, but Amazon's basically running Zen under the hood. So you can tell when the instance is up and running. Once it's up and running, you can do another query and say, hey, I want to know what the public IP address of that box was that you just created. Now we have an IP address. We have the name that we're going to use to name the IP address. Let's go update DNS. Put it in the batch update queue that runs every hour. And we've just created a new spot instance. And then we regenerate that Nagios Extra, whatever it is, dynamic host.cfg file that contains all the lists of hosts that we've generated using Nagios. So, my opinion, our little delta C here saves money, because a small percentage change in how many things you're using can result in a pretty big change in the cost of goods. So if you've got 100 calls, and again, we're quantizing in 50 units, so that's 2 boxes running. That's going to be about $75 a year. That's nothing. Let's go to 500 calls. Now you need 10 boxes running. You're about a little less than $400 a year, probably a little bit more based on bandwidth and usage. 2,000 calls. Now 2,000 calls is a large number if you're talking about one customer, or even 2,000 customers. Actually, no, not 2,000, sorry, 200 customers. The average rule of thumb, though, is you can expect between about a third and a fifth, I did that wrong, about a fifth and a third of your capacity to be in use at any given time. So 2,000 simultaneous calls is really maybe 5,000 phones on people's desks. If you've got customers that have 20, 25 phones each, this is really only a few dozen customers that this represents, or potentially represents. So now you're looking at $800 or so a year. And if you go up to 5,000 simultaneous phone calls, you're talking about 50 boxes running. Now maybe we need to rethink what kind of box we're running at that level, but it's going to cost us about $2,000 a year. These numbers are example only. This is not indicative of our actual underlying business model for what these things cost us, but you can see if this is actually my last slide. I wanted one more after this, but if you've got a historical usage pattern that says all of my customers are in the eastern United States, and they're busy from 7 a.m. until 7 p.m., and I have nothing happening from 7 p.m. throughout the rest of the night, there's no need to have 50 boxes running to be able to support 5,000 phone calls. You could probably drop down to 1 box running at that particular moment in time. And so if you look at just saving a 12-hour period, you're looking at a 50% of the time, not including weekends, it's even more if you include the weekends. 50% of the time, you can get away with something that's going to cost you probably $50 a year to run. The rest of the time, it will cost you $2,000 a year. So you put those percentages together, and you're looking at, instead of $2,000 a year to support 5,000 calls at any given time, you're looking at less than half of that, and probably a little bit more than half of that. You're looking at about $1,000. So you can cut your costs dramatically by only paying for what you need, when you need it. And Nagios is the backbone of how we've done this. So I'm pretty sure that was it. I don't know how long I am, but you're welcome to ask questions if you'd like. I'm thinking
All
nobody has
right, do
questions.
we have any questions?
So I asked if you actually do any work, because if the customers fill in a web form to order phones and stuff from you, and
Yep.
that goes into the capacity planning, and then Nagios sets everything up, it looks like you've been doing work for, well, couple of days, and then you can cash in on it for the rest of your life.
Well, have you read the book 4 Hour Work Week by Tim Ferriss?
Yeah.
Yeah, so I work about 4 hours a week. No, I really don't. I mean, do you see how long this PowerPoint presentation was? I mean, this took
Yeah,
time.
that must have taken you like 3 days
This
to
was
make.
like,
at
yeah,
least.
and getting that little blinky thing at the bottom to be just annoying perfectly, that was a lot of effort. You know, yes, obviously we do work. This didn't happen one day when I said, I got this great idea. I'm going to sit down and totally automate our provisioning process. This has been going on for 18 months. I'll be honest, I'm cheating a little bit when I say, I don't know why I'm pointing this there. This, for instance. We don't do this. We can, we don't. There's some things that we could do that are pretty easy to do given what we've already architected that would make this even better. But this is a long series of events that led to here. And it's based on scripting and automating and all the stuff that goes into making that happen. Fighting with DNS is half the battle, which is why we have 59-minute TTLs at this point. And try as you might, I don't know any business that simply says, yeah, we got a website, and people just go to it and they buy stuff. You have to market it. You have to figure out who you're going to market it to. You have to figure out what your special of the day is that you're going to get that person to sign up and not this person or whatever it is. Now, there's a lot of business that goes into the business. The other side of this is there's a lot of care and hand-holding that we do with our customers so that they don't have to know how to program phone systems in order to get a phone system that's programmed the way they want. This is provisioning boxes and to some extent provisioning phones. The magic happens in getting the right data in the database. So there's the old joke, maybe it's not so old, I don't know. The cost to hire a contractor or a consultant to push the button is $1,000. But the cost of hiring a consultant or a contractor who knows which button to push, that will cost you $20,000. So getting the right data in the right database and getting it in the right format, that's not automatic at this point. We have people who enter things into a web page, but we still need, for instance, when you become a customer of ours and you want to keep your existing business telephone number, you got to fill in a form, you have to send us a copy of your telephone bill so that we know you're authorized to make changes. So that's not something that goes into a web form. We have to do something with that. We have to actually port that phone number to our platform. That's something that's done manually, essentially manually. It's done through a web interface, but somebody's got to do it. Talking to you about, well, how many phones do you need? How many extensions are going to be on each phone? How are those calls going to flow through your business? Those are all things that require, I say hand-holding, but it's a discovery process where we walk through what your call flow is going to be. If you're a 4-person business, it's going to be pretty simple. You want the phone to ring, you want all 4 phones to ring, and if nobody answers, it goes to a voicemail. If you're a 40-person business, it could get more complex, and if you're a 200-person business, it can get very complex, especially if you have receptionists and secretaries and people who answer calls for other peoples and all the other peoples, for other people. So there's a lot of work that goes into figuring out what that customer wants. Provisioning process, we got that down. We don't have to touch boxes anymore. That's great, because there used to be a lot of time where we sat there and twiddled our thumbs waiting for Amazon to start a box up so that all we could do is copy and paste the IP address that it gave us into DNS so that we would have the thing that we needed to put into our provisioning database so that we could put that into the phone database so that the phones could figure out what proxies they needed to talk to. And when like I said, if the last line had actually showed up on all these things, that sounds like an event handler to me. And why don't we have Nagios do this? Because we're putting the data in the right places. We just get tired of clicking go all the time. Let's have Nagios do it. So looking for the host was the key to all of this, rather than telling hosts to be created and saying, Nagios, the host is up, you should be able to go look at it now. We just said, Nagios, go look for the host. If it's not there, make it. And if we don't need it anymore, either because we turned the customer down, reduced their capacity, or because it's now 7:30 p.m. and we don't need all that capacity, we can tear those instances down, again, through Nagios without having to go create a separate process. So I understand what you're saying. There's a lot of work that goes into it. Ideally, I would love to say, yeah, I don't do any work at all. I come here, I talk, I show PowerPoint, I go home, I drink Mai Tais. That would be ideal. But I'm not quite there yet. Yes? Well, I guess you need a microphone now.
So you've talked about a couple different ways that you kind of decide when to have provisioning actions, right? So you sign a customer leaves. Do you do any sort of, and you talked about how you spin up instances based on capacity. Is that something that happens like during the day, or so a customer gets a, they just ran a ad on The Price is Right, and all of a sudden they've got, 5,000 calls coming in. How long does it take for that to show up? Rather, how long does it take to ramp up the capacity for them?
Sure. So the answer to your first half of that question is this is happening right now as we speak. Day, night, weekend, work day, vacation, whatever. Because the platform doesn't, hopefully, it never reduces capacity beyond or below what is currently in use. We're never removing services that are being used. So if you've got, I'm just going to make my math easy because I can't do complicated math in my head. I'm not from NASA. If you've got, let's say, 99 phone calls going on, and so you're one away from that 2-box Quanta, 99 is really close. Do we really want to say, well, it's not 100, but do we want to add more capacity? Or maybe it's 101. You say, well, it's not 100. Do you want to remove capacity? We kind of get fuzzy when we're near those border numbers. But if you're using 75 calls and we've got a platform that's currently configured for 200 calls, then we'll drop it down to whatever the appropriate number of boxes are. Now, the one thing that's not up here is we don't say, well, we had capacity for 500 calls the last time we ran, and we only need 60 calls now, so we need to plan for 100. We don't drop it down to 100. We drop it down 1 quanta. So just like atomic physics, we're going down 1 electron. We're only going down 1 energy state. So we go from 500 to 450 to 400 to 350 to 300 to 250 to 200 to 150 to 100, and we do that in 30-minute intervals. So I don't remember how many that was, but that was about 4 hours or whatever worth of work before we went from 500 to 100. That's strictly based on Nagios looking at current usage and saying, you got more or you got less than what you're currently configured as. In the background, cron is out there looking at that performance data from histories saying, well, pretty much every day at 7 o'clock, we go from 2,000 call capacity to 200 call capacity. There's no point in waiting 5 hours or whatever it is to trickle that down. We just cut it. So cron says, you were at 2,000, now you're at 200. And if Nagios comes up and says, oh, you really need 250 or you need 400, it will build it back up. So we build up in whatever we need based on Nagios, and we come down one at a time except through cron. So the platform, it's not just like a smooth curve in terms of capacity. It's kind of jumpy and jaggy here and there. It's mostly jaggy going up and smooth coming down. And as far as the time frame, as far as the time for that to happen, customer says we're going to put an ad on The Price is Right and we're expecting 2,000 phone calls. They're not going to tell us that. You don't call up your phone company and say, hey, phone company, I'm expecting a whole bunch of phone calls. Do you guys have capacity? The first thing is they need to have the capacity to be able to support that. And if their bandwidth and their network can't support, let's say, 2,000 phone calls, then it doesn't matter how much capacity we have. There's never going to get those extra phone calls. But were that to be the case, the ramp-up period is I'd have to do math based on the intervals, but something on the order of about 30 minutes from we're okay to, oh God, we're in panic situation, and then boom, we've got the capacity at that interval, plus however long it takes for Amazon to actually spin the instance up. Does that answer your question?
Yes, thank you.
Welcome.
So mine's probably a fairly simple question. You are tracking your performance data historically. So, and sounds like you're using Core. Are you using PNP? What are you using for your historical data?
Somewhere on one of these slides, it says that something that's very important to us is Twitter notifications for custom notifications and custom modules. All of these checks are done in custom modules that extract that. There's basically a wrapper around each of the checks that takes that performance data and just throws it into a SQL database.
So it's a homegrown
Yep.
kind of a thing.
So you could think of it as our own version of RRD that takes care of managing the data, and then something which goes and does something with it like PMP, but we're not looking at pretty graphs. We're talking about that delta C check actually says, as part of what it does, is it says, go get me the last 3 lines out of the database and figure out what the average is. Are we going up or are we going down based on that average? So we're making use of the last 30 minutes basically worth of call usage for Nagios. Cron is looking at kind of longer and different time intervals, but it's doing that based on pulling data out of a usage database that was populated by the check itself.
Okay, thank you.
Yeah. There's one in the back.
Hey, I apologize if you addressed this earlier, but did you ever look at the rate of change of the rate of change? Would that ever be a meaningful metric for the amount of calls?
We have talked about whether that's meaningful or not. I mean, we have that information because it's just one more slope we can calculate. But the rate of change of the rate of change isn't as important to us as how big was the rate of change. So, if we're looking at that second derivative that you're talking about, we're talking about, well, are we talking about a really big slope? Or are we talking about a really small slope? What we're more interested in is we needed to go from 100 capacity to 1,000 capacity now. And looking at that change of the rate of change is going to give us sort of a smoother average kind of thing. The bottom line is we have the information available to us if we want to look at it. Just not sure that it really gives us anything, given what we want to do is adjust capacity to meet current demand.
Couldn't you look at the rate of change to predict demand 30 minutes from now to spin up VMs right just before you need them?
We can. So I'm hesitant because this is kind of an ongoing battle. You asked if we actually do work. Yeah, we sit around and we argue about what we're going to do. So we could get kind of crazy in terms of predicting the future, and are we going to spin things up? Are we going to not spin things up? Are we going to be proactive and not proactive? We have a pretty good understanding of what our overall usage pattern is. Based on the information that's in the database from the custom checks that we've got, we know, we can't predict that Price is Right advertisement, for instance. But we do know what a general call volume is throughout the course of the day. Since cron is out there taking care of those kind of larger changes over time, we decided we have yet to run into a case where we have not been able to dynamically adjust to meet demand. So we're calling it done, and we're just going to see if we need to fix anything later.
Any additional questions? All right, ladies and gentlemen, how about another big round of applause one more time for Eric Loyd. Thank you, Eric.